So we've talked about exponential functions, we've graphed exponential functions, and today we're going to solve exponential and logarithmic equations. And basically those are equations that involve, logarithmic or exponential expressions. One or two rather sample exponential functions are these two here, okay? Notice the difference. In the one case, you've got one base, one power raised to a constant. In the other case, you have two powers equal to each other, okay? Now, the property that we normally use to solve exponential functions or logarithmic functions is the one-to-one property, which says if you have identical bases raised to different exponents on either side of the equation, then you could just set the exponents to each other. And you can probably, I don't even need to prove that to you, because you could already reason out that if you have something like this, 3 to the x equals 3 to the 5, then x has to be 5, right? You set the exponents equal to each other. So without further ado, let's just do a couple of examples. The point then is to get the bases of the powers to be equal to each other. They don't necessarily have to be, in this case, you have a 4 and a 16. You don't have to make both of the bases into 2's. They just have to be equal to each other. So this is 4 to the x plus 2 equals, what's 16? X minus 3. And now I could just set the exponents equal to each other. So it'll be x plus 2 equal to 2x minus 6. So x is equal to how much? Right, 8. All right. Now the next one, on the one hand, I have 2 over 3 to the power of x minus 5 equal to, how can I write 9 over 4 in terms of 2/3? Negative 2, correct? Because not only do I have to square it, I also have to take the reciprocal. So the 2 squares it, the negative takes the reciprocal, times 3x over 4. So then I'm going to set x minus 5 equal to negative 2, 3x over 4. No, because the other side is like the smaller base, right? It's you just want to make the two bases equal to each other. Just like here, we had the 4 and the 16. You could do it that way. Or
yeah, but doing negative 2 times negative 1/2.
Yeah. Right. You could do both. Because you want to make it equal to 9 over 4. All right, so this is going to be x minus 5 equal to negative 3x over 2. So 2x minus 10 is equal to negative 3x. 5x is 10, and x is equal to 2. So far, not too far off from algebra 2, right? Now, in the case of the next one, 4 to the power of x equals 13. Okay, right, logs. But now, I know in algebra 2, mechanically we say, oh, just take the log base 4 of both sides. But let's reason it out in terms of what a logarithm is, right? Remember how at the very beginning of this chapter I said, okay, I have 2 squared, 2 to the 2 is 4, 2 to the 3 is 8. Well, 2 to the what? Remember I said 2 to the what would give you 6, and then I said that's a logarithm. So the exponent is a logarithm, right? So the exponent x is the logarithm base 4 of 13, right? Is what I have here in purple the same as the equation on top, right? It is. Because when I see this on a billboard, x equals log base 4 of 13, immediately I think 4 to the power of what equals 13? 4 to the power of what equals 13? Now, if that's a little bit too revolutionary for you, we could do it algebra 2 style, and we could say, okay, log base 4, log base 4, and here I have log base 4, 4x, x equals log base 4 of 13, okay? It's the same exact thing. So what I have here is log 4, 4x equals log 4, 13. And then x equals that. So now that I have this, if this is, let's say, on a non-calculator section, you would leave it as is. To put it in the calculator, we can do change of base. Okay, so the newer models of the calculator, you could just put it with the base. The older versions, you couldn't, and you would have to do, yeah, it's math, and then the A option. 3 decimal places. 3 decimal places.
1.850.
Thank you. Okay. In the case of this one, e to the power of what equals 2.8. So basically, look, the exponent is a logarithm, right? So here's what I'm going to do. Watch. The exponent is log base b of the number. Okay? The exponent in this case is what? 2x plus 1 is equal to, what's the base? E. Log base e is ln of 8. Okay? So 2x is equal to ln of 8 minus 1. X is equal to ln of 8 minus 1 over 2. Okay? And what is that when you put it in the calculator? 3 decimal places?
0.540.
Thank you. Okay?
So why would you put an ln?
Because it's a base of e. Technically, you do log base e, which is ln. So what we would do in algebra 2 was ln. Okay, ln of both sides. Yeah.
I don't know if we're gonna. Well, actually,
Okay. Now, what if we had logarithmic equations? Same situation. If you have identical logarithms, like log base 2, you could just set the arguments equal to each other. X equals 6. Okay? All right, so take a look at this one. First, let's divide by 2. So ln of x is equal to 9. Okay, now, logarithm is equal to a what? What's the answer to a logarithm? It's an exponent. So that's telling me that this is an exponent. What's the base here? E. That means I say x is equal to e to the 9. Yeah, okay? How did we do it in algebra 2? We had ln of x equals 9, and then we did e to the ln of x equals e to the 9. So x was e to the 9. Same situation. E to the 9 is too big a number. Okay, so how big is too big? Normally, if it passes the hundreds and it goes into the thousands, it's too big. We just leave it as e to the 9. Even like e squared, like on a non-calculator section, leave it as e squared. It's more of an exact solution than 7.4 is. Okay. Here, negative 3 log 10x equals to 6. Divide by negative 3. Log 10x equals to negative 2. Where in here, in that mess, is the exponent? The negative 2. The answer is always the exponent. What's the base here? 10. So then, 10x is going to be 10 to the power of negative 2.
would the 10 just cancel out though?
No, because it's not log base 10 of 10, it's log base 10 of 10x. So, yeah. Huh? Right, but this is 10x. We're not done yet. So x is, look, we're going to divide by 10. So take a look here. X is 10 to the negative 2 divided by 10. It's 10 to the what? Are you sure? Negative 3. You subtract the exponents. Okay? So 10 to the negative 3. So this is 1 over 1,000. We don't leave negative exponents. So that's 1 over 1,000. You know I always prefer fractions. Okay? Okay, here we go. In this mess of this problem in C, where is the exponent? 20. What's the base? 5. So x to the 4 is x to the 4 is equal to the base to the power of 20. Not yet. Yeah. Now it's x to the 4. What are we going to do? We're going to take either the fourth root, or the fourth root is the same as to the power of 1 over 4, right? Since it's all about exponents, I feel like this is, easier. So x is 5 to the 5. Again, leave it that way. Okay? Okay, here we're going to use the 1-to-1 property. I have log base 5, log base 5. I just set whatever is inside equal to each other. Don't you guys love logarithms? I know I do. So it's x plus 5, x minus 4 equals 0, x equals negative 5, x equals positive 4. Now, I know. So and specifically with logarithms, you want to check that your answers work. Okay, so check both answers. And in this case, it's not too difficult. You can see that they both work, right? Because if I put negative 5 in here, then I get 25 minus 5 log of 20. If I put 16, I get log of 20. You want to make sure that they work. You also want to make sure that you never have an x value which gives you log of a negative number. Okay? All right. Here, first, I want to condense this. So that's going to be log base 2 of 10 over x minus 4. That's why we did the last section. And that's log base 2 of 5. So now we set the arguments equal to each other. And then, we do a little bit of algebra 1. 5x equals 30. It looks like x is equal to 6. Okay? And now does that work here? I'm going to get log 10 minus log 2. But that's log 10 over 2, which is log 5. Yeah, it works. You don't have to do it in your head. You can always write it down, but I don't want to insult your intelligence too much, so okay? Now here, notice you have two variables, ln of y equals negative 5x plus 3. So what we want to do here is we just want to solve for y. This is one of the problems that I put in anticipation for calculus, because a lot of times we've noticed that students see a problem like this and all of a sudden like, oh my God, what do I do? Okay? So, yeah. It'll tell you. Normally it's going to be for y. You use e. You use e.
Wait, so what happens to that?
It becomes the exponent.
Okay, what is ln? It's log base e of y equals negative 5x plus 3. In this mess, when you have a logarithm, where is the exponent? This is the exponent. So in here, this is the exponent. And what's the base? Base is e. So we say y is equal to e to the negative 5x plus 3. And that's it. We can't do any more. That's all we do. Okay?
I like that.
I know. Okay, now I have a base of 3. I have a base of 3 and I have a base of 2. They're different bases, but I'm going to take the same logarithm of both sides. So what I'm going to do is I'm going to take the ln of both sides, and it's going to look like this. Ln of 3 to the power of 6x minus 3 equals ln of 2, 4 minus 4x. Now, don't freak out on me. We can figure this out. Okay, what happens when you have log of something to a power? What happens to the power? What can we do to it? It turns into a coefficient. So this is going to be 6x minus 3 in parentheses times ln of 3 equals 4 minus 4x times ln of 2. Now we're going to distribute those ln's. So it's going to be 6x ln of 3 minus 3 ln of 3 equals to 4 ln of 2 minus 4x ln of 2. Now, can I combine like terms, or can I bring everything with an x to the left side and everything without an x to the right side? Of course I can. So 6x ln of 3 plus 4x ln of 2 is equal to 4 ln of 2 plus 3 ln of 3. Now, I'm going to factor out an x. Okay? Let's factor out an x. You can, but it's not going to take you too far, so we'll just leave it in there. Okay? Plus 4 ln of 2 is equal to 4 ln of 2 plus 3 ln of 3. Now I divide. So x is equal to 4 ln of 2 plus 3 ln of 3 over 6 ln of 3 plus 4 ln of 2. Okay? It seems like a bit too much to swallow, like too big of a bite to swallow at first, but when we do the second one, don't take anything out just yet. Hang on. Now, here's what we're going to do. I'll take questions in a second. Here's what we're going to do. Can I combine that? Can I condense this? Can I write this as in the numerator ln of 2 to the 4 times 3 cubed? Of course I can. And in the bottom, can I write it as ln of 3 to the 6 times 2 to the 4? Huh? I'm condensing. Yeah. Yep. Yeah. So now let's what is 2 to the 4 times 3 cubed? So 16 times 27. How much is that? What do you think? How much? 432. And on the bottom, what is that? ln of what? What's 3 to the 6 times 16? That's too big a number. We'll leave it like this. Okay? Huh? No, because it's ln of and ln of. They're, yeah. Okay?
That's the answer?
Yep. It's not possible to cross out ln's. It's like if you had a root, like root x over root y. You can't cross out the roots, can you? Yeah.
If the numbers were smaller, would you like find the actual ln?
It would still be like ln of 4 over like ln of 3. We leave it in terms of ln's. All right, let's do one more. Let's take ln again because it's so much fun. So 2x plus 4 times ln of 6 equals negative x plus 1 ln of 5. 2x ln of 6 plus 4 ln of 6 equals negative x ln of 5 plus ln of 5. Let's take the x's to the same side. So 2x ln of 6 plus x ln of 5 equals ln of 5 minus 4 ln of 6. And I'm going to take out an x because I can. I can. And you know what I'm going to do this time? I'm going to condense here before I divide, because I can do that too. So this is going to be x times ln of 6 squared times 5. Right? How much is that? 36 times 5? How much is that? That's like 180, right? Equals ln of 5 over 6 to the 4. Yeah, because I'm taking all the x's to one side and everything without an x to the other side. So this is 180, right? That means x is equal to ln of 5 over 6 to the 4 over ln of 180. Well, yeah, because it's ln of and then ln of. Yeah. Okay, now this. Remember back in the day, we used to, when life was nice and easy, we used to factor things like this. And this was like the biggest problem we had, right? And then we said, let's make things difficult. And then we had this, and everybody was like, oh my God. And then we said, oh, no, it's the same thing, because instead of factoring as x and x, we now factor as x squared, and everything else stays the same, right? Why were we able to do that? Because what we had was a constant, an expression, and then that variable squared. A constant, a term with a variable, and then that variable squared. So suppose now I had something like this, 6, and then here instead of 5x, I had like 5e to the x, right? What would the square be here of e to the x? E to the 2x. Moral of the story being, even this I can factor in quadratic form. But now, instead of doing x and x, or x squared and x squared, I now have e to the x and e to the x. Okay? So let's do one, shall we? Here. E to the x and e to the x makes e to the 2x. And now two numbers to multiply to negative 2 and add to negative 1. I am going to go with negative 2n plus 1. Okay? Now I set these individually to 0. And I get that e to the x equals 2. And what's x then? I take ln, x equals ln of 2, and that's a totally fine number on its own. We leave it as ln of 2. It's fine. Yeah. No. E squared equals x? Oh, but if in a logarithm, but this is like e to the x equals 2, there is no logarithm, it's all a power. Right, like the answer to this would be a logarithm, that's the thing. The exponent will be a logarithm, you see what I mean? It's the other way around. So here I have e to the x equals minus 1, x equals ln of minus 1, but what's up with that? Not possible. So this is the only answer. Okay, so here we add 3. And then we divide by 40. So far, not very exciting at all. Then I take the ln of both sides, and I get that 0.6x is equal to ln of 6. Yep. And we can put that in the calculator. And what, because we don't want to mix 0.6 in a fraction. And what do we get there? Ella. Thank you. All right. Okay, so what do you guys think we should do next or first in the next one? Condense. Okay, so have at it, Maya. Okay, what now? What now? Okay, who's going to carry on the torch? You can set the arguments equal to each other. Well, now we go at it like Algebra 2 style. Multiply by the LCD. So 7x plus 3 is 2x squared plus 2x. Yes. Will do. So 2x squared minus 5x minus 3 is equal to 0. There's also a screencast of this, so you guys could watch it again, thanks to Brandon. So now we'll totally know if you watch this, because if he didn't, he'll be oblivious to this whole thing. Okay. So what do we think here? I'm going to go with a 3 out here and a 1 here. Huh? Well, all right. Let me have your attention for a minute. So we solved this, and we got x equal to -1/2 and 3. Now, if I put the -1/2 in here, look at what I get at the very end. ln of -1, which will not work. But we're hoping x equals 3 will work. So, next one, lots of 12s. So here, log base 12, 12x times x minus 1 equals 12. Where's the exponent? This 12 is the exponent. What's the base? Right. So 12x x minus 1 is equal to 12 to the 12. And then, hang on, don't plug it in yet. Let's divide by 12. So x minus 1 is equal to 12 to the what? Ooh, hang on, there is an x here as well. Yeah, okay, so look here. Log base 12 of this equals 12. In that expression of the logarithm, the number that the log equals to is the exponent. This is the base. So this mess, 12x, x minus 1, equals to the base to the exponent. Okay? So what I have here is x squared minus x minus 12 to the 11 is equal to 0. And surely we can factor that, yeah? Or not. We can't factor that. So this is a calculator problem from here. But you see how to set it up. Hang on. Before I get there, this will be due tomorrow, okay?